Hello, everyone. Clay from Claiborne LSAT. I'm here to give you the setup for one of my favorite all-time games, although I have to admit it wasn't my favorite when I first encountered it. Many students probably feel this way. It's one of those weird miscellaneous games that popped up several times, especially in that range from prep test 72 to 80. And as you know from clicking on this video from the title, it is the last one in prep test 79, the famous computer virus game. So I'm going to start there and just note this is prep test 79 and the last game. And as always, out of respect for copyright, I'm not going to read out the actual wording of the game to you. I'm not going to put it up on the screen. Let's just go ahead and dive in on the setup of the game, keeping in mind a few general things that are worth saying here about the odd miscellaneous games. One characteristic of these kinds of games is that you have to spend a lot more time in the opening paragraph or prompt than you usually do. Normally, if you get experienced at logic games, you jump in and you immediately see, oh, sequencing, grouping, like it just kind of lines up. And it's where it's when the rules come that you're spending more time really building those inferences. We certainly need to spend a lot of time with the rules, but this game requires some more time with the actual paragraph and just thinking about the implications of that. First off, that the virus came from outside the network. So we need one computer receiving it from the outside, and then it was transmitted around, but that should raise the question, well, does that just mean that everybody got it once and it kind of went around? No, if only it were so easy. We do know that, however, that each computer did receive it only once. That doesn't mean, however, that they transmitted it to another computer only once. So we have 6 players here who are all receiving something. There's going to be arrows kind of going back and forth, but we have to keep in mind that they're each only going to get it once. If somebody gives it twice, then somebody else will give it not at all. So there's a possible kind of asymmetry to the giving or the transmitting of the virus. We then get another piece of helpful numerical information in the first rule. And this is the kind of sentence that would often just be in the prompt itself in the opening paragraph. And that's that the maximum for transmitting is to 2 others. So we're not going to have a scenario where a computer gives it out to 3 or 4 or 5 others. But as we mentioned, it could give it to just 1, it could give it to 0. As you come to the rules, you need to always be thinking about number possibilities, even on this weird miscellaneous game, or to put it another way, thinking about the parameters, like what's one extreme and what's the other extreme to which it could go. In this case, it's basically just 0, 1, or 2 for the giving or transmitting. And then the rules get more specific. Now, I've done this game a number of times and have settled on a method that I think is by a large margin the best approach. And even though this is a weird miscellaneous game, we are going to apply some of the same principles here that we do on other games. We like to talk about the star player, which is just our way of talking about the element in the rules that appears the most, or that is restricted the most. Now, it's not easy to tell who that is right away because there are actually several of the computers that are mentioned more than once. But I'm going to home in on S, primarily because of what happens in that second rule, or the first one that describes S. That's really the only computer about whom we know exactly how many it gave the virus to. We don't really find that out about anybody else, but we know that S gave it out exactly once. So I'm just going to start out with kind of right here in the middle, this kind of arrangement. And I'm doing this, I'm starting here because, again, S is a star player. It's mentioned in another rule that is very specific. And so I think that's going to help me set up kind of a core here, what you might call sort of a core of the framework. We know that the same computer, whatever it is, gave it to both R and S. That's what the third rule is telling us. We don't know who that computer is yet, apart from the fact that it can't be R or S itself. You can't give the virus to yourself or give it back and forth just between R and S. That's not what the language is saying. Whatever computer it was gave it to both R and S. But see, what this does is it establishes for us kind of a core, as I mentioned, which looks to contain only 2 players, but it really contains 4 players, or at least 4 spaces. 4 of the 6 players are going to be bound up in what's happening here. And we can just now start to kind of toggle, well, who could fill those blanks? Who could fill the blank giving to R and S? Who could fill the blank after S? Well, the only 2 remaining rules is about who gives the virus to Q and who gives the virus to P. Nothing immediately tells us who might go in this spot, but why not just toggle the options? There's only 4 left, P, Q, T, and U. And again, this is where our decision tree method tends to set itself apart from most approaches. Instead of just kind of leaving that blank and hoping for an inference, we're going to stop staring and start scribbling and say, what if it's P right there? What if it's Q right there? What if it's T right there? And what if it's U right there? That should be all that can happen. And maybe it's not that many ways. So let's just start out with P. If P is the one that gives to R and S, well, we know something else about P. We know that either T or U gives to it. Nobody else can. So we got that. And now that leaves the other one of U or T, and then also Q. All right, well, we could put U/T here as the other option, but we also need to know who's giving it to Q. So I'm actually going to erase this and toggle it instead. And what I mean by that is, sometimes you think, well, this is an either or, I should just put a slash. But if it's going to affect something else, you should actually play it out. You should decide, what if it's this? What if it's that? Let's say that it is T giving to P. That only leaves Q and U now. But see, Q is never eligible to receive it from S. So if T is here, then U has to be here. It's the only one who could fill that place. Q receives it from R or T. So the final thing I would do, since it's not really going to affect anything else to decide this, is just indicate with a dotted line. It's not going to look very pretty. Dotted arrows coming from both T and R to Q. Dotted line indicating maybe T gives it to Q, maybe R gives it to Q. It's a little messy, but it gets the job done. It shows you what's possible. And then we proceed through the decision tree process as usual. We say, all right, well, we picked P to give to R and S. Did we toggle anything after that? Yes. We were thinking about whether that was T or U next. So I'm just going to come over here a little bit more to the left. I'm going to label this number 1 because I wanted to start in the middle. But I'm going to come over here a little bit more and recreate the core that we're going to recreate every time. This core of R and S giving it to blank, and blank giving it to R and S, which in this case we know is P. So the remaining thing is just that U gives it to P. And remember, that means that T has to be over here. T and U, one of them is going to have to fill this slot, an inference that is very important to make in this game. Because again, Q cannot be the one to receive it from S. R and T are a little bit closer together in this case, making it a not quite as messy diagram to say one of these, R or T, gives it to Q, and this is number 2. Okay, now we're done putting P in this space, and we just need to toggle through Q, and then T, and then U. It might sound like a lot, but remember the general principle for these advanced game boards. We tend to say, 10 is probably too many. Less than 10, usually worth it, especially if you discover essentially everything that's going to happen. So I'm going to draw the core up again, R and S receive it from the same computer. We already tried P, so we're going to go in alphabetical order. The next option for that is Q. Now, this prompts things a little bit differently. Well, in a very similar way to T being there, except that R or T must give it to Q. Well, that's nice because we know R doesn't give it to Q in this case. R's over here. Somebody else is going to have to give it to Q. And it has to be T in this case. Notice that as before, we have to fill in the U here because nobody else, because Q and U are the only ones left. Q cannot receive from S, so U goes there. That leaves just Q left, which always receives it from T or R. This is going to be a long line, so I'm just going to start an arrow and then make it dotted, kind of like that, dotted, arrow, Q. Either T or R gives it to Q, and voila. The cool thing about, no, not the cool thing about that, because I already used Q. We typically don't rewrite these videos when we make a mistake because that happens sometimes when you're doing logic games and you have to redo something. It's what we do in the middle of our tutoring sessions. I was mistakenly reusing Q when I should have been looking at P, that either T or U gives to P. Well, that actually could be either one of them. Maybe U gives to P, or we'll make a really long line. Need to have part of it be dotted at least to indicate that. Let's try that again. Dot, dot. And we'll put P at the end of that. We don't know if it's T, we don't know if it's U, but one of them gives to P. And now we have all 6 of them in there. And what I was about to say, when I was so rudely interrupted by my own mistake, is that in this option, unlike with toggling P in that spot, we actually only need one example with Q in that spot. So things are starting to kind of narrow down already, as they often do. In other words, it looked like it might be taking something like 8 advanced game boards to get this right, but it's actually looking now like it's going to be fewer than that because we're done with P and Q and we have 3 examples. Let's see what happens when we use T and U respectively. So we're going to start with T. Now, what applied before still applies because you have to remember neither Q nor P we've discovered can go in this spot. S is not listed as one of the possible ones you can give to Q or P. We know exactly who those are from the last 2 rules. So once again, this is always either T or U. If T is there, then U is here. Now, here's where it gets a little bit trickier. We have to think about the role of T in this case, and especially remind ourselves that T is now done. Don't forget about the first rule. T has transmitted to 2 computers and is completely exhausted. T is for tired. No more giving, right? Well, that's beautiful because T is involved in both of those last 2 rules. So since T is not an option, we know that R has to give to Q and that U has to give to P. And that's the cleanest option yet. There's no other possibility. If T is the computer that gives to R and S, that's it. That's all that can take place. It looks like we're almost done, even though at first glance, this might have looked hopelessly complicated to try and draw it out like this. Granted, this is never going to be an easy or simple game, but you can see how it's coming to a place of mastery with a few examples. The only remaining player to give to R and S is U. We know from many examples now, therefore, that this has to be T over here. And let's consider what then happens to Q and P. T is not bound up like it was on the last one. It is totally free to get to others. Now it's U that's bound up. U is exhausted, can't give to any more, so can't give to P. So T must be the one giving to P, leaving the only uncertainty being a kind that we saw before about whether R or T is the one that gives to Q. There we go. And that actually did it. I was moving to the left to leave enough space just to make sure I could get in the 5 examples. because this just spreads out. It doesn't look like a usual logic game. So we have the equivalent of kind of handles on a sequencing game, or the slashes that we use sometimes for either ors. We have one here, one here, one here, and one here. Even still though, that's actually a surprisingly small number of game boards to master what appears to be such a confusing scenario at the beginning. In 5 examples, you've given yourself everything you need to answer the questions. That is the power of the decision tree method.